Today I'm going to get started on a project that's really just something I've wanted to do to try to push my machining capabilities and skills. This is one of the tool holders for the Acroloc, and part of the way this functions, there's actually this top ring, and then the actual tool holder is the rest of it. These rings, I've got somewhere around 15, 16 of them total. 12 of them sit in the machine at all times, and then the rest of them I kind of swap out as I need them. What I would like is significantly more of these rings, so that's what I'm going to look at trying to build today. Let's go ahead and head over to the bench and have a look. Okay, so we've had at least a few days of just sort of mildly unpleasant warm weather. Just getting a little bit over 100. And the air conditioning in the shop has actually been doing enough to make it where I'm not dripping sweat within 10 minutes. So I'm going to go ahead and kind of start going over a project I've been wanting to do. So in the Acroloc, these are the tool holders. It's got its own custom tool holder, which is, it's got a lot of its own problems, but it's actually designed with the automatic tool changer in mind and the way they actually hold everything in. So each of the tool holders snap into the spindle and then come down and do any of the cutting. So this piece is actually what holds it in the automatic tool holder or tool changer as a ring, and it basically goes on here, and it has a little lip that actually holds it in so that the spindle can come down, hit it, and then it pops out, and then it comes back up, pulls it off the spindle, and then it can change to the next one. So these rings, I do have, technically I probably have enough of them, and as I need new tools I can actually pull them off. The tool changer has room for 12 tools. I have, I think, 15 or 16 of them, so I have a couple of extras that I can swap out between tools, but they kind of look like an interesting project. The process for putting these on and taking them off, so they have these little pins here that go in and out. So when it's mounted in the spindle, these pins come on the inside and grab a hold of the spindle, and then this ring here is spring loaded, and it actually keeps those in place. To mount it on a ring so that it's ready to be put into the machine, I use the press here. I avoid the actual tool and then compress those springs, and then I can get up in here and you'll hear the click, and that's just pushing those pins out of the way, and then they actually clip onto the ring here. So now, as you can see, the taper fitting in here is clear so that the spindle can come down. Now these little pins here, what holds those pins back into place. So now they're protruding into this ring and actually holding it. So if I put it in the tool holder, the tool changer, it will be able to just basically suspend itself in place. Now back over here, to actually remove the ring, I come over to the other side. I've got a rubber mat here so I can gently set it on the tool, and I'll mostly hold it with my hand, but I can come into these pins and press them down, and each of these will come out, and then the final one will actually release the spring tension that's on the main tool holder part, and then the whole piece comes out. So the most ideal would be that every tool holder like this that I own, which I've got a little over 100 of them, would have a ring, and that would make it the easiest. Whenever I need to pop in a new set of tools, I can just pull them out and drop them right in. I don't have to go through that process. Not that it's a difficult process. Any friction would make me try to substitute a different drill or a different end mill that can do the job with the perfect end mill that's made to do the job. And it seems like a fun project to actually try to make one of these. So I had gone through and measured all of the components, trying to figure out what the original dimensions and specifications would have been for this particular piece. And a lot of these measurements have been really difficult to figure out. So I have found that this is a 30-degree angle going in this way, and then each of these others are 45-degree angles on the insides here. Cross-section shape of this I have outlined here. Looks like that. So that would be, if we were to take a cross section here. So I've got specific measurements that I was able to get to really fairly precise. And then a couple of these, I kind of give my little tilde next to as, they were approximately how close I could get. But I wasn't necessarily able to measure them. Some of them may be eyeball measurements, kind of like, this here, figuring out about how big that is supposed to be. And through the measurements I found it to be somewhere around 75 thousandths. So these were the measurements I knew I could play with, probably within 10 thousandths to try to get everything else. So, and then some of the others were, the bottom of this channel here, coming in this way and, kind of estimating about where they're supposed to be. And then peak to peak, kind of doing the same thing, coming in this way and kind of getting an estimate. And I found that to be almost exactly a ½ inch. So I figured that was probably what the original intention was for those. So taking all of this and putting it into a sketch in Fusion, no matter what I did, I could not get these guys to come really even close. They were about 75 thousandths off of what they're supposed to be. Really, I don't even know where my errors in measurement were that would actually bring everything this far off, unless these 45 degrees are, ever so slightly, maybe they're 44 degrees or something. But the only tools I have for actually measuring this particular angle is just a regular protractor, which gets me close. And because they are really close to 45 degrees, I would have kind of assumed that they likely were 45 degrees. But unless I have a better way to actually measure those, then that's going to be kind of what my assumption is. So I've been able to use, I picked up this micrometer, came in a toolbox, never really figured what I would actually be able to use it for, but it actually came in rather handy for getting these, basically this measurement, from the bottom of this lip to that peak, and this measurement from here to here. It was helpful for getting in there and getting those measurements. I have this little domed Anvil micrometer that I was able to use to get inside and measure the thickness of the inside of this valley, and came up with 55 thousandths. So this was actually one of the few tools that, or few machinist tools that I had inherited from my father, and he was a heavy equipment mechanic, and sometimes you needed to measure things, so he did have a couple of small measurement machinist tools. So to get in here and actually cut that out, I've got a relatively large chunk of high-speed steel here, probably much larger than it really needed. But I'm actually going to come in and create a boring bar with the 45-degree profile trimmed out. So it'll be something similar to all of that, which should give me a tool that I can use to come in and cut this channel. So this will be something I actually get to use my tool and cutter grinder for. So far, I did a quick rough job on the belt grinder, just to kind of get my outline. I didn't go quite as deep as I had originally drawn because I don't think it really needs to be that deep. But this gives me the chance to come in and double check. Not sure if you can see, but I can definitely get in and reach all of that inside feature. So now I can take this and actually set it up on the Tnc grinder and grind in those angles and get everything, you know, perfectly set up. Alright, my first setup on the Tnc grinder, I've got my back relief of about 10 degrees and the actual cutter edge set at the 45 degrees. Just used a protractor up against that to make sure I was at the 45 degrees. Now I just got to get suited up and ready to go. Actually, I got to get this guy plugged in first. I've got a new 3-phase tool that I've been working on and been borrowing this plug. Alright, so I've got my angle set up here at a 45. I'm not sure, I don't love this setup, but I think it should work. But I can just come in this way and bring that edge over. So while cutting that, I actually just realized I'm cutting my relief angle the wrong direction. So I have this angled this way 10 degrees, it needs to be angled this way 10 degrees. Alright, now as you can see I've got really good 45-degree angle cutter with a neutral rake. For steel, I better double check, so I think I should have a slight negative rake. Let me double check my lathe cutting book. Alright, I double checked. Little Machine Shop says for cutting most alloy steels, you should have an 8 to a 15 degree back rake. So that's going to be going this direction here for this particular cutter. So we're going to go ahead and mount it in here and tilt it just a little bit. Alright, this isn't really the best setup. I should actually be using a regular wheel. I don't actually have a good regular wheel, all I have is this cup wheel, so we're going to use it and actually just go vertically this way. Alright, so I spent a little bit of time with a stone, and I got a nice sharp edge, and I just rounded off the tip just a little tiny bit, and I think that this will actually get in here and allow me to cut this inside feature here. I think this is a good start. The next video I will actually cut the stock. I'm not sure if halves or thirds. I want to make sure I have the right amount of stick out so that I don't get too much chatter, and we'll start giving one of these a try, see if we can make one.